Thank you. Good afternoon. And now, okay. So I wanted to talk a little bit about the challenges of infrastructure development if we are developing automated mobility solutions. As a little bit, my background is I am originally have a longer background in the automotive industry, so traditional car development. But over the years, I got first exposed to connected vehicle technology, and then most recently more to automated vehicle technology. So I will give you an overview, I think, what is important from an infrastructure development perspective. So if we go to the next slide. Well, I can do that, yeah? Okay. Yeah. So first of all, if we see what is happening in the automotive industry right now is you see a change of a business model where the old model is selling the car, making the profit per unit sold, to providing a mobility service where you basically have to figure out how do you make your money by the transactions that the user triggers when he demands the service. And that is a big change for the car industry for multiple reasons. So first of all, if you are, because it questions basically car ownership in the traditional sense. So if I own a car, I determine how much I use it. If I'm using mobility as a service, each time I'm triggering that request, I'm expecting a car to come and pick me up, or basically something has to happen. And the focus is moving towards fleet management of vehicles. And that has an impact on the infrastructure. So what we see right now is, on the one end, that from driving the car, we are now becoming a passenger. So even in the younger generation, it's not on the #1 priority list to have a driver's license. So much more important is that they have a smartphone and they can use the service. It's also interesting that we're seeing some changes that car manufacturers are trying to offer you a more flexible usage model, so a subscription service, so to speak. So depending on what your needs are on a weekend may be different than during the workday, that you can choose between different car models and mobility services. What is also important is that our shopping behavior is changing, so that the goods have to be delivered to us, then we drive using our car to pick up the goods. And that's why there is now a whole industry around delivery robots and delivery systems developing. And last not least is that our the way we pay is also changing, that basically mobile payment becomes more accepted, and we could even have the car itself having a digital wallet and pay for specific services. So this chart is quite interesting. It is a more visionary outlook into 2030, and how the mix of mobility systems is changing in the next approximately 10 years. Now, what this particular study is predicting is that the use of private cars and the use of public buses will be substantially reduced and will be to a certain degree replaced by the use of autonomous vehicles and robotaxis. Now, whether that is exactly correct in the proportions, that's to be questioned, but in principle, it reflects why the car industry is looking at this and basically trying to figure out how do we play this. And it has obviously infrastructure implications, because if we have if we have less private cars on the road, it has, for example, an impact on the parking infrastructure. How much parking infrastructure do we need? Do we need special lanes for autonomous vehicles and so forth? Another important point is, as we are moving forward to highly automated mobility systems, is that instead of thinking about a particular vehicle category, we now have to think about multimodal mobility systems. And how can I basically switch the mobility mode in my path from A to B? And as more of those vehicles are being electrified, I have to start thinking about the charging infrastructure, and I also have to think, because more of these vehicles are having a high number of sensors, about what is the impact on the communication infrastructure, and do I need 5G networks, or which type of network technology has to be there. So another interesting point is that as the vehicle is being more automated, and more automated, highly automated vehicles are hitting the road, the mixture, the ratio between the automated vehicles and the non-automated vehicle will continuously change. And that's a challenge, because that has an impact on the reaction patterns. So if you have an intersection, all vehicles are manually driven, we have a certain way how to respond. If half of those vehicles are automated, they have to start interpreting what the manual vehicles want to do in this situation. And if all of them are automated, then it might be easier. But again, I want to basically say that by the influx of more level 3 and level 4 automated vehicles, we have here a dynamic situation. Another important point in terms of the technological and regulatory challenges here is that, on the one hand, I need to anticipate situations already in a simulated environment. So basically, I need to have simulated test environments, and then I have to go into what we call hybrid environments, where we basically expose a real vehicle to a number of simulated vehicles, up to a full physical environment, and then to a deployment scenario. So there are different steps how we introduce automated technology, which basically means that it's not just about testing automated vehicles on public roads. There was a race between different states that said, well, I have the most progressive regulation, and Florida is one of those states, basically, to test autonomous vehicles on public road. But that is not the only criteria. It is actually the integration between what can I test in a simulated environment, what can I test in a controlled environment, and what can I ultimately test on public roads. That has to be well thought through, and there are different use cases that have to be applied to the different environments. Interesting enough, what we see, and I'm quite involved in the development of test facilities, that originally testing a car was something that the OEM had to do. He had specific OEM-owned facilities called test tracks to test the vehicles in different conditions. And then they obviously also did road testing, public road testing, but a lot of the critical tests were happening in dedicated test tracks. Now that we have a mobility as a service system developing, a lot of different players have to work together: infrastructure providers, IT companies, the car manufacturers, the suppliers. And that ecosystem basically has to start using what I call a shared facility. So we see now an increasing number of projects where test beds are being designed as shared facilities. Another important point is that the requirements in a highway situation, in an urban environment and a rural environment, are very different. So it's debatable whether the fully automated vehicle will first come in a highway or in a rural environment or combination, but you have, for these different environments, you have to derive test cases and to go through these test cases. And in order to go through these test cases, you need something which we call scenario. And that is like a language. So you basically have to describe the environment where a specific vehicle maneuver is happening, which are the other vehicles being involved, are there pedestrians involved, are there bicyclists involved, and so forth. And that whole scenario is being described in a specific way. And right now it is very difficult to find a common language because there are different interpretations what a scenario of a specific situation should be. I'm working quite heavily in a consortium effort where we try to standardize these scenarios. So then what is also important that testing in a, as I mentioned before, in a controlled environment versus a simulated environment, we need to learn which are the relevant scenarios both from the real world, but we also have to, in the simulation environment, come up with specific scenarios that might happen very rarely or are even unlikely to happen, and to understand it from both directions, from the simulation side as well as from maybe certain accidents or interactions or incidents that happen in the real world, and we have to learn from that over the time. So I skipped that. Another important point is that we are finding ways to classify the road infrastructure in a way that we know, okay, with this road infrastructure, we have all the ingredients to deploy a highly automated vehicle. So it's not only that we can expect the vehicle to operate in any infrastructure environment, we have to classify the infrastructure environment and then say, with this classified infrastructure environment, I can apply those automated vehicle services without a problem. And if this infrastructure environment is changing, I might have to reduce the level of automation. Last but not least, I also want to mention that where do I get the data from, which is very important. So some companies, like for example Waymo, so Google, Waymo, were quite secretive about how they collected their data. The data was not shared. You have other companies that have a different approach. So the question is also from a regulator perspective, how much data does the regulator expect to be shared from the vehicle and from the fleet operator, from a safety perspective, from a security perspective? And so I wanted to give you an example about what is happening in 30A. We will hear more details from Jay and from Raul in the panel discussion related to what we want to do here. So 30A is an area in the northwest of Florida which has a number of beach communities which are connected by a road called 30A. And the problem of this area is that it has a lot of traffic issues during high season. Everybody wants to park close to the beach. Everybody comes with a lot of family members or other, so there is basically a high aggregation of private cars in a limited amount of space. So how do you solve this? And how do you solve this problem? It has a big economic impact. There are basically every year several million visitors. It generates a lot of income for the region. So Robert Davis, who is the founder of Seaside, which is one particular community that started that 30A, let's say, region development. So Robert had this vision of we need to develop a new urbanism concept, so walkable communities where we are not designing the beach community to be car-friendly, it needs to be friendly to the people. And in this basically environment that I suggested, that I just described, where we have now a lot of congestion, he was very frustrated, and he said, well, isn't it possible with autonomous vehicles and automated driving to find a street layout where I can reward those who are not using their personal car and using basically a shared service. And that is here an example where you have only one lane. And that was one of his suggestions. Could it be one lane where you have autonomous vehicles driving in both directions, or do you have a dual lane system? And so that was his question, his vision. He said, well, we need to find a way how to come to new street layouts to leverage these technology advances that I mentioned before. So a problem is basically lack of parking, road congestion, and you cannot just widen the road because it's not possible in this environment. So this led to the idea to really develop what we call a mobility as a service infrastructure. And here the thought is that you have a multimodal mobility service where you can park your personal car in a remote parking area, and then you have different options how you move around. You can use an AV shuttle, you can use a bicycle, and so you have different mobility modes, and that's basically the approach. Now the big question is, what kind of infrastructure do we need to have in place? How do we need to change the road layout? What kind of charging infrastructure do we need? I noticed that in 38 the cell phone service was very limited, so you need to improve the communication infrastructure. All these things had to be considered. So now I would like to show you finally a video. This video is showing a real AV shuttle in Seaside operating. But the story behind the video is more that are we already trusting our children to use such a vehicle to go to school? And I think that most of us that have children would feel quite uncomfortable. So we will ask the questions, how safe is this? Who is doing the safety assessment? What use cases are being covered before we actually would trust our children to use such a service? So I would like to show you this short little video at the end of my presentation. Thank you very much.